看一下有没有声音。它声音那个大吗？听得清吗？细小的声音。我讲了，它有延迟。然后你看一下它这个画面会不会卡？应该不会卡。Yes, I will speak English. I'm testing with my college just now. And our live will begin at 3 o'clock after 6 minutes. Okay, okay, everyone. Now it's 3 o'clock. Let's start our training. And let me introduce myself first. My name is Jim. I'm mainly in charge of PLC, and this time I will bring the A500 series training for you. And you can see this is our training schedule. We will use two class to introduce the motion control, single axis and the axis group. And then the training will be based on ST programming language. And then we will use another class to introduce the expansion module applications. And today is our first training about single axis control. And this is our today's contents. 3 parts: axis introduction, axis configuration, and axis application. First, let's see the define of the axis. In A500 systems, we call the control object as the logical axis. This picture you can see the axis is used to associate between the driver and the motion function block. So in our PLC A500, we have many different type of axis type. For example, encoder axis, EtherCAT axis, and post axis. This is the control status of our axis. We can see here we have 8. Here we have 8 status of the motion axis. After power on, the status should be disabled. And after we use, for example, MC power function to enable our axis, the status will change to standstill. And here, if we use some function block, for example, MC move absolute, the status will change to this discrete motion status. And here, if we use, for example, we use MC stop function block to stop the axis, the status will change to stopping. And after the motion, after the stop application is finished, the status of the axis will change back to the standstill. So here we can use some function block, for example, read axis status to get the current running status of our axis. And this picture shows the relationship of the status changing. Okay, next part is about axis configuration. I will show you how to add axis in our A500 PLC software. First, in the software in the project, I will show it later with the software too. Here, in the project management, we can see this EtherCAT button, and we right-click it. You will find this Add Slave. And here we have built in some VD3E EtherCAT ESI file. So we can add this to our project. And after we select the EtherCAT slave and create it, the axis will create it automatically here. And this axis will be bound to this EtherCAT slave station. So we don't need to configure other things. Okay, and also, if you double-click this axis, you will find this output device. You can select and change to other station, EtherCAT station. Here, if we want to communicate with other brands driver, we can click this import and select the ESI file of other brand driver, import it and add it to our project. After adding the axis, we need to do some basis configuration. We can this is the page of the configuration. First is the axis number. This number is used to bind the function block, because in function block we need to define the axis ID to decide which axis we need to control. So this axis number is very important, and it is Unicode identifier for the axis. And this second axis type, as I said, we have these 3 types: EtherCAT axis, encoder axis, and post axis. For the input device is reversed now, and output device, here we can select the axis, EtherCAT axis or local post axis. Depends on the axis type we selected. And for EtherCAT axis and post axis, we can select this virtual mode. After we click this virtual mode, it means we can simulate. We can do the project without the real driver connected to the PLC. And the last is this automatic mapping. If we are using EtherCAT axis, we need to map the PDO and PDO to our bus servo axis. So this is default checking. And double click our axis, we can see this unit conversion setting. This conversion setting is used to set the relationship between our user unit and the parameter in our function block. How to understand? In our function block, for example, we need to set the target position, maybe 100, 200. And what this 100 means in a real machine, maybe 100 mm or 100 cm and so on. So with this setting, we can, this setting is used to set the user unit. Some parameter we need to fill in. First is the PPR of our motor. It depends on the motor encoder. For example, for 16-bit motors, here we enter this value. This is yes, this value. And next, we need to set the this user unit. We can do some. For example, if we use default unit, 1 unit, it means in the function block, if we set the target position as 1 and do the movement operation, the motor will rotate 1 rod 360 degrees. This is the default setting. So how to associate the user unit to our function block parameter? We can do some tests, for example, like this. First, we control our motor to rotate, for example, 1 rod, and measure the real distance the motor move. For example, one rod it move 12.33 mm, and then we can set this parameter as 12.34 units. So with this setting, when we set the target position as 20, for example, 20 in our function block, the motor will move 20 mm. If we set the target as 3.5 in our function block, the motor will move 3.5 mm. So here we can enter the user unit in our function block. It will be easy for user to use it. And here, if you have the gearbox, you can check this one. Use a gearbox and enter the gear ratio according to your reducer. Next part is about axis parameter setting. Here, let's introduce this one by one. First is the speed curve type, velocity curve type. For now, we support S-type, T-type, and this quantity curve. We support three different curve type. And here, second is the software limit. If we enable this software limit and set the forward limit and negative limit, when the PLC will detect the current position real time, and if the current position is beyond our limit range, the PLC will stop setting the command to the motor, and the motor will stop in the limit position. So this is the software protect for our motor. And second is the third is our flowing arrow. This parameter means the next flowing arrow allowed by the system, because there will be a delay between PLC send the command and the servo begin to move. There must be some delay, and this delay will generate this throwing arrow. So we can set this throwing arrow to, for example, if the motor is stop at some position, maybe static, but the PLC is continue to set the pose. So the throwing arrow will become bigger and bigger. And when it achieves this throwing arrow setting, the PLC will report error and stop the motor. And our engineer need to check whether they have some machine code problem. And the next two is velocity setting and torque setting, speed and acceleration deceleration limit setting, forward and backward torque limit setting. This is the parameters setting for our axis. And here, this here also have this origin return setting. This is for homing operation. Here we built in some built-in homing mode, and here you can see with different homing modes. The homing logic is displayed in this picture below. And we can select the suitable homing mode according to the installation of our limit sensor and the home sensor. And here also we can set the homing speed. We have two speeds, homing speed and the speed return speed. And this setting is used to help to select the homing mode. It's something like filter. Okay, this is the setting for the homing operation. And the last is the online debugging. With this function, we can quickly do some tests about our axis after we installed the motor to the machine. Here we will display the actual value about the position, speed, acceleration, and torque and our torque value, and also status, run status, homing some status of the motor. And here have a button, inter-servo debugging. Here we can use some function, for example, set the position, set the home offset, and forward jogging and backward jog, and also some control modes. We can check it here. After inter-servo debugging, we can enable an axis, and here we can jog the axis, disable. Oh, sorry, I didn't connect the PLC. Doesn't matter, we can check the function supports here. Here I have some absolute positioning, relative positioning, and the continue motion. Here we can give one speed, target speed, and then the PLC will control the motor to move a fixed position. And it's back to our presentation. And the last Last part is the ST application about the single axis. In this part, I will introduce some commands function block for the single axis control. Here, first one is MC power. This function block is used to enable our axis and some input parameter and output parameter. For the input parameter, here axis, we need to bind an axis ID. And you can check the axis ID here. In the front of the axis name, here we have the number. It is the ID number. And enable is a racing edge trigger to enable the axis. And also we have these two inputs, positive, enable positive and enable negative. This is used to set a lot running direction for the axis. Usually we set this to input as true status. So after enable axis, we need to read the position and read the velocity. So we can use these two function block. MC read actual position and MC read actual velocity. These two, the input and output terminal of these two function block is similar. We can see here we only need to set the axis ID and trigger the enable input, and we will get the position feedback and display it in the output terminal position. And here we can bind it to our variable. This is the velocity is similar similar to read position. Also, we can add this arrow read function block to read the error or fault of our motor. So it will be easy for us to do the troubleshooting. And also, we only need to bind the axis ID to this function block, and we will get the error ID on the output terminal. Set position. This function block is to set the relative or absolute position of our axis. We have two modes for relative mode and actual mode. For example, if our current absolute position is 100, and then we set the position as 200 with the absolute mode. After setting, the position will change to 200. But if we use, if we set 200 position with the relative mode, the position, after setting, the position will change to 300. Because 100 add 200, we will get 300. This is the function block, absolute move function block. Here we have some, here is input terminal, trigger, execute, used to trigger the running. And the continue update is, if we set it as true, then we can change the target position and target velocity real time. And next is our target absolute position, target velocity, acceleration, deceleration, and drag, some motion control parameter. Direction is only used, take effect in rotation mode. In linear mode, we don't need to set this parameter. And the buffer mode, axis ID, some output parameter. These two absolute move and relative move is very similar. The only difference is in relative mode, we don't have this direction. It's the only difference. Other parameter is same. So, so now I will connect PLC and to run this function block to show you how it works. Let me check the commands. ST is the programming language like this. This project is ST language, and we can create it. You can see here. For the official software, we support these two programming language, ladder language and ST language. And, okay, please share. Yes, I will show it. For the gearbox setting here. Here, if you have a gearbox, for example, maybe 110 reducer, so you can directly set here. So it means the motor rotates 10 loads. The position will increase one unit in our function block. In another word, for example, with this setting, if we set our target position as 20 in the function block, then the motor will rotate 200 loads. Okay, for the ST, for example, here, if you want to create a new variable, you can switch the input type. Here we have table type and list struct type. In table type, you can click this button to add variable, name the variable, and set the type of the variable. And you can also use this form to create each variable. For example, test, and name the variable as test, and here we can set the type of the variable, bool and real, int, and some other type. So now, after this, we can use this test variable in our project. And for the function block, for example, we can create one enable axis, and we set this variable as the MC power. Okay, so now in the project, we can use this enable axis to enable our axis. Here, I enter enable. Okay, here, and click enter. We will get this, and now we need to bind variable to the input and output. Output is not necessary. If you don't need this output variable, output information, you don't need to bind variable to this. But for the input, we need to bind the variable. And if you stop the mouse on the variable, here you can see the variable type supported by this parameter. For example, this enable, it only supports bool type, and also these two, enable positive, enable negative. These two is also only supports bool type. And axis ID is according to, for example, if you have many axes, if you want to enable this one, like here you need to enter 3. So I need to now let's download the project to PLC. Okay, and here, first let's enable access. How to change the status of this variable. Here you can right click and add it to variables window. Here I have already added to this window and set the preparation value and write it to the function block. Okay, now we can see here the status of the axis is true. True means the axis is enable status, and we have no error. And the reading position is 200. Reading velocity is 0. Let's try this set position function block first. Global position 1. We set this as 500. And trigger is input to write the value. Okay, you can see after trigger this function block, the reading position is changed to 500. And if we set this mode to relative mode and write again, we can see the reading position is changed to 1000. And set the position as 0 absolute mode. Write the trigger this set position again. The position is oh sorry, I didn't write this target position. Try again. Okay, now position is changed to 0. Absolute 0 position. And next is absolute move. Let's try. Let's directly run it. It's in the reading position is this is our setting velocity 20, and it achieve our target position 100. We can set this target position to another value, for example, 1000. Here we get an error because this function block we didn't set it as we didn't set the input of this execute to false. Now let's run it again. And because we set this continue update as true status, so we can change the velocity. This one to, for example, 30. Wait a moment. Target position. Here we get one error. Let me check. Oh, sorry, because in axis parameter, we set the speed limit as 20. So here, when I set the target velocity to 30, we get one error and stop. And for the error, we can use MC reset function block to reset the error. Okay, let's try again. First, enable the axis and run this absolute move again. Its goal, the velocity is negative value because the current position is bigger than our target position. So it will go back and stop at 100 position. We write this new target position and run the function block again. And now we can change the velocity to a smaller value, for example, 10. You can see here the target position is real time changing. Okay. So this is the usage of the move absolute, and for the move relative is similar. The usage of move relative is similar to this absolute. The only difference is the target position is based on relative position. So we can skip this step. Okay, so this is our today's content about single axis control. In fact, we have other, for example, you can see here in motion control, single axis management. All these are used for single axis control. We have also this one, I said, MC reset, and also read axis information, read axis error. But here I didn't introduce LAN or all of LAN because it's too much. And also for the motion we have MC stop, MC home, and others. For the usage of this function block, you can check it in our WECON support center. We have a very details in introduction about this function block, and you can also find the demo project in WECON wiki platform. And next class is next Wednesday. I will introduce the axis group control for the A500 PLC. With the axis group control, we can do the interpolation control, linear interpolation and circle interpolation, 2-axis system or 3-axis system. For this function, we need to use axis group control. And the next class is also launched by me. And so see you next Wednesday. And this is our today's training. Okay, do we have any other questions? You can type here, and I can give you answer. motion control. You can keep this link. Here I have the most details introduction about all function block. All right. Our A500 PLC is use same manual with LX6V and 6S because they use this same software, and the control function block is also same. Okay, if there are no questions, we can end our today's training after 1 minute. Okay. You have VT5F driver, but it not shows hardware limit. Sorry, what do you mean not shows hardware limit? Because in PLC, we can only set the software limit. For the hardware limit, maybe you need to connect the limit sensor to the driver side or to the driver side. To, for example, forward prohibit or backward. You can see here. Maybe you can use DI of the driver and connect your limit sensor to the driver side for the hardware limit. Positive direction driver prohibition and negative direction prohibition. But here we only have software limit. Okay, any other questions?